insert overhead line insulators. It is basically for third year electrical engineering students. First some theories will be there, and after that, as usual, mathematical derivation it will be covered. You know that the insulators have arrangement to support the bare line conductors from arm members of towers or poles. And the span between the two towers is dependent on the allowable sag in the line. And now the insulators are designed and manufactured for a certain voltage range, and the maximum voltage per insulator is about 33 kilovolt. Now we describe the types and characteristics of line insulators. And the types of insulators, there are 4 types of insulators. Number 1, the pin type insulator. Number 2, suspension type insulator. Number 3, strain type insulator. And number 4, shackle type insulators. Now look at this figure. This is the pin type insulator. The conductor is supported on the top of the insulator. And up to 25 kilovolt, this type of insulator are made in one piece. And above that voltage range in more than one piece, but they are used for up to 50 kilovolt only. For high voltage, they become uneconomical. This is the suspension type insulators, and in this case the conductor is supported at the lower end. A number of insulators in the form of discs are used together in a flexible string to attain the desired voltage range, and the disc nearest the conductor has the highest voltage trace. Now the working voltage can be increased at a small cost by adding extra insulator units. And this is the advantage of using suspension type insulators in high voltage lines. Now come to the strain type insulator. When a string of suspension insulator is used in a horizontal position, and when used in such a position are known as a strain insulator. They are used at the line terminals or at road or river crossing. And up to 11 kilovolt shackle insulator are used for this purpose. For low voltage distribution lines, shackle type insulators are frequently used as a strain insulator. These insulators are also used in section poles, end poles, and on shelf cars and for service connections. Insulators for overhead lines. Then types of insulators. This is the pin type insulators. This is the suspension type insulators. This is the strain type insulators, and this is the shackle type insulators. Let us start the next topic, that is the potential distribution over a string of suspension insulator. Here is a figure, the string of 4 insulator. Now the potential distribution among the various units of a string insulator is not uniform. That means the V1, V2, V3, V4, these are the potential distribution, because the capacitance is formed between the metal parts of the insulator and the tower. But it is possible to decrease the capacitance. So how this capacitance is decreased? By increasing the distance between the insulator and the tower. That means the lengthening the cross arm, but which are not economical. Now come to this point, the C1, C2, C3, C4 and C. This C1, C2, C3, C4 are known as a self-capacitance. That means the capacitance of each insulator unit is known as self-capacitance. And on the other hand, the capacitance between each insulator unit and the earth or say support is known as the mutual capacitance. Now let M equal to capacitance per insulator divided by capacitance to ground. So I can write C1 equal to C2 equal to C3 and C4 is equal to, that means the capacitance per insulator is equal to capacitance to ground, that is the C. So you can write this is the MC. Now let V be the operating voltage. That means line to ground. Line to ground, that is the V. And V equal to V1 plus V2 plus V3 plus V4. So we can write V equal to V1 plus V2 plus V3 plus V4. Where the V1, V2, V3 and V4, the voltage drop across the unit. Now come to this figure. Now we apply the KCL at point X. So you can write I2 equal to I1 plus IC1. We can write I2 equal to I1 plus IC1. I2 equal to I1 plus IC1 by applying KCL at point X. Now we can write I2 that is equal to omega C2 V2. Omega C2 V2. That is the omega C2 means MC, the omega MC V2. Similarly, omega MC V1 plus IC1, that is the omega C V1. Omega equal to supply angular frequency. So we can write V2 equal to V1 into 1 plus M by M, or we can write V1 1 plus 1 by M. This is the equation 1. Now, also by applying KCL at point Y, we can write I3 equal to I2 plus IC2. I3 equal to I2 plus IC2, or we can write omega C V3 equal to omega N C V2 plus omega C IC2. That means omega C V1 plus V2. V3 equal to V2 plus V1 plus V2 by M. V3 equal to V1 by M plus V2 into 1 plus 1 by M. Now put the value of V2. V1 1 by 1 plus M. So put this value V1 1 plus 1 by M, 1 plus 1 by M, or we can write V3 equal to V1 M square plus 3M plus 1 by M square, or V3 equal to V1 1 plus 3 by M plus 1 by M square. Now come to this figure. Now the KCL apply at point Z. We can write applying KCL at point Z. We can write I4 is equal to I3 plus IC3. I3 plus IC3. Or we can write similarly omega MC V4 equal to omega MC V3 plus omega C IC3. That means omega C V1 plus V2 plus V3. So you can write V1 plus V2 plus V3. Or V4 equal to V3 plus V1 plus V2 plus V3 by M. Now put this value of V3, that we know that the V3 equal to V1 M square plus 3M plus 1 by M square. V3 equal to V1 M square plus 3M plus 1 by M square plus V1, we can write 1 by M plus V2. We know that the 1 plus M by M square plus V3 M square plus 3M plus 1 by M3. From the previous discussion, that is the V2, V1 1 plus M by M. So you can write V1 1 plus M, M square, or V4 equal to V1 M square plus 3M plus 1 by M square plus, after computing this we get 3M square plus 4M plus 1 by M cube. Or we can write V4 V1 M cube plus 6M square plus 5M plus 1 by M cube. Or V4 equal to V1 1 plus 6 by M plus 5 by M square plus 1 by M cube. Normally, the value of M greater than 1. So you can write V1 less than V2 less than V3 less than V4. If you put any value of M in this equation, you get this one, V1 less than V2 less than V3 less than V4. That means the lowermost unit is the fully stretched. That means, come to this figure, that is the V4. Is the lowermost unit, this is the full stretched. Now the string efficiency. String efficiency is defined as the voltage across the string divided by N into voltage across the unit adjacent to line, but N is the total number of insulators in a string. So we can write from this figure voltage across string, we can write Vn, that means 4, V4, voltage across the unit adjacent to line, that is the V4. Potential distribution over a string of suspension insulators. This is the diagram of potential distribution across a string for 4 insulators. This is the self capacitance, this is the mutual capacitance. This is the string efficiency. Now let us start the next topic, that is the methods of improving string efficiency. If the insulation of the high stress insulator, that is the nearest to the conductor, breaks down or flashover takes place, the breakdown of other units will take place. This necessitates to equalize the potential across various units of the string, that is to improve the string efficiency. Now these are the three methods of improving string efficiency. The first one, the selection of M, and the second one, grading of the units, and the third one, that is the girdering. And come to the first point, that is the selection of M. We know that the performance of the string is dependent on the value of M. As M is increased, so how M is increased? By increasing the length of cross arm, and which reduces the shunt capacitance. So the division of voltage become more equalized. But M is say 10, then it is uneconomical. So come to the next point, that is the grading of the units. So look at this picture. We know that the unequal distribution of voltage across each disc of string insulator is due to the leakage of current from the insulator pin to the tower structure. It is not possible to eliminate this leakage current, but it can be reduced by equalizing the voltage across the discs using different capacities of discs. So, to equalize the voltage across each unit, the topmost unit of the string, that is the unit nearest to the cross arm, must have minimum capacitance, and the bottommost unit, the unit nearest to the power conductor, must have the maximum capacitance. So come to the third point, that is the girdering. So come to this picture. By using the girdering, it is possible to make the voltage distribution uniform among the discs. The girdering is a large metal ring and is connected to the metal work at the bottom of this unit and to the line. And it is then possible to cancel the pin to tower charging currents by making the same amount of current flow through the units of identical capacities. That means I1 equal to I1 dash, I2 equal to I2 dash, I3 equal to I3 dash, up to In minus 1 equal to I dash n minus 1. Then the voltage drop across each unit is equal. The methods of improving string efficiency. The first one, selection of M. Then second one, grading of units. And the third one, girdering. Come to this simple example. Determine the maximum voltage that the string of the suspension insulator in figure can withstand if the maximum voltage per unit is 20 kV. Here is the figure and given C dash is equal to C by 6. Now, first apply KCL at point A. So we can write I2 equal to I1 plus IA. So we can write V1 omega C plus V1 omega C by 6 as C dash is equal to C by 6. Or we can write V2 omega C, that is equal to 7 by 6 V1 omega C. Or V2 equal to 7 by 6 V1. Now applying KCL at point B. KCL at point B. We can write I3 is equal to I2 plus IB, or V3 omega C V2 omega C plus IB, that is equal to V1 plus V2 into omega C by 6, or V3 equal to, after computing this value we can write the V3 equal to 55 by 36 V1. Now come to this question, that if the maximum voltage per unit is 20 kV, so the voltage V3 across the unit near the power conductor is maximum. So we can write V3 is equal to 20 kV, or 55 by 36 V1, that is equal to 20, or V1, after computing this we get 13.09 kV. Similarly V2, 7 by 6 V1, 15.27 kilovolt. So V equal to V1 plus V2 plus V3. We can write 13.09 plus 15.27 plus V3 equal to 20. 48.36 kilovolt. This is the answer. Now I will put a question here. A line conductor is suspended from the cross arm by a string of 4 discs insulators. Calculate the conductor voltage with respect to the cross arm if the voltage across the second and third units from the cross arm are say 13.2 kilovolt and 18 kilovolt respectively. Then what is the string efficiency if leakage current is ignored? This is the question for you.